Okay, so real quick right here, this setup is very similar to our foldable that we just had, okay? So what you're gonna do with this worksheet, you're gonna convert, yeah? So the foldable that we just did to go from representative particle using Avogadro's number to get to the mole, and then of course, you will need the molar mass in order for you to go from the mole to grams, okay? We're gonna do the same thing, but this is what this diagram is showing you exactly what we did with the foldable. So if we start off with atoms, you cannot go from atoms to grams without having to go through moles. So with that said, you're gonna go from atoms or molecules, particle, so this right here will be RP. Whatever your RP may be, atoms, molecules, FUs, ions, doesn't matter. In order for you to go from RP to moles, you're gonna have to use Avogadro's number. Avogadro's number is right here, okay? So if we follow the arrow going from here to here, you will have to divide by Avogadro's number, which is 6.02 times 10 to the 23rd, whatever RP is, okay? Now remember, you're gonna divide by this number. If you're going from moles to RP, you will have to multiply by Avogadro's number. Yes? All right, now, here's the molar mass. It's grams per mole. If you're gonna go from moles to grams, right here, you have to multiply by the molar mass. If you wanna go from mass to moles, you will have to divide by the molar mass. Now don't forget the units for molar mass. This is equal to the units of molar mass. Okay? Now, just a quick reminder on what is the molar mass. We will do this first. We'll do this first problem. I'm going to do it in a bigger sheet of paper so that you can see. So we're going to do sodium bromide. Now remember that in doing sodium bromide, you have to first separate the atoms. So we'll separate the atoms Na and Br. That's the first step. The next step is to determine how many subscripts. Well, there's numbers down there, so that means that there's one of each. Then the next step would be to determine the mass of each substance. So I'm going to use pencil so that you see that I'm going to multiply the mass of sodium, which is going to be 22.990, which we're going to round to 23.0, okay? For bromine, it's going to be 79.9. And then you're going to multiply horizontally. So it's going to be 23.0 times 1, which is 23.0. And then it's 79.9 times 1, which is 79.9. Then you're going to add them up, and you're going to end up with 0.9, 12, 7, 8, 9, and 10. So that's your molar mass. Make sure you put your units for sodium bromide, okay? How about number 7? Let's go to number 7. I'll do the first two since they're up there on the top. So that was number 4. How about we do number 7 now? Okay, so number 7, make sure you're writing this down on your sheet of paper. For number 7, it's gonna be sodium, Na3PO4, sodium phosphate. Again, we're going to use Na, separate all the atoms, so you have Na, P, and O. Okay, as you separate the atoms, the next step would be to determine the subscripts of each substance. So you're going to determine Na has what? 3. So you're going to put a 3 there. P has no subscript, so it's going to be 1, and O has a 4 of a subscript. The next thing would be is to multiply by their respective molar masses. For sodium, again, from the previous problem, we said it was 23. Phosphorus is going to be 30.974, which is going to be 31.0, and oxygen will be 16.0. You multiply horizontally, and you end up with 23 times 3, it's going to be 9, and then 69, 31.0, and then 16 times 4 is 64. You add them up, you end up with zeros at the bottom, the decimal, 14, and then 12 plus 4, 16, right? So there's your molar mass for sodium phosphate. Okay, make sure that you do 5, 6, 8, and 9.